In this lecture, we'll be starting the looping constructs in C++. We will first look at while loops, then do-while loops, and then for loops. And finally, we will finish up with break and continue statements when used inside the loops. Let's first look at the need for looping construct in programming languages. Often, we would like to repeatedly execute some statements for as long as a condition is true. Let's motivate this by computing a to the n, where a is a floating point number and n is an integer. For example, let's compute 3 to the 5. Obviously, in order to compute 3 to the 5, we need to multiply 3 5 times. So we need to say 3 times, 3 times, 3 times, 3 times 3. So as you can see, there are 5 multiplications in here. So you're multiplying 3 with itself 5 times. Here is a code that does it, assuming that n is known in advance, n is 5. So we are actually writing a program to compute a to the 5, right? A is something that we're going to get from the user, but we know that we only want to compute a to the 5. The way we can do this is we can declare a variable double power, which is equal to 1 to start with, which kind of represents a to the 0. A to the any, 0 power of any number is equal to 1, as you know. So because we would like to compute a to the 5, we need to multiply power with a 5 times. So we say power multiply is equal to a. So now at this point we compute a to the 1. If you multiply power with a again, then it power becomes a to the 2, which is the second power of a. Then we multiply power with a again, then it becomes a to the 3, and so on. After the fifth multiplication, power becomes a to the 5. This is example 1 in the example code. So let's go there. In this case, we are now looking into the examples in O4 looping construct. So go there, open the folder with VS Code, and go to example 1. This is the code. Again, this code only computes a to the 5. We are going to read in the value of a from the user and initialize a variable power and then multiply it with a 5 times. And at the end, the value of power would be a to the 5. So let me debug this one step at a time so that you see how power changes. So let's wait until the program starts. Let's go to terminal. We need to enter a number. Let's just enter 3 for the time being. So let's enter 3. Now I want you to watch the values of a and power on the left hand side. So power is 1, right? So after the first multiplication, obviously power would be equal to 3 because 1 times 3 is 3. This is the computation of 3 to the 1, right? So we multiply power with a again. It becomes 9 because 3 to the 2 is 9. Then we multiply power with a again. It becomes 27. 3 to the 3. Then 3 to the 4, 81, and 3 to the 5, which is 243. And that's what we print on the screen. So bottom line is, if we know the value of n, if the value of n is fixed and we would like to compute a to the n, in this case n is equal to 5, so we always want to compute a to the 5, we can write the code like this. So we can write 5 multiplication statements multiplying the power. This is like the running power at this point with a 5 times, and we get a to the 5. But what if n is not known in advance? Then clearly we need to execute power times equal to a, this statement, n times. We were able to write the code on the left hand side 5 times. We were able to multiply power with a 5 times because n was fixed and the value of n was 5. That's why we were able to write 5 multiplication statements, and that used to compute a to the 5. But if n is not known in advance, we don't know how many power times a statements to write. That's why we need looping constructs to actually execute this statement, power times a, n times. That's where the looping constructs come into play. So the idea is the following. In order to compute a to the n, we keep a running power initialized to 1, which is exactly what we did in the previous example. We kept the running power 1 initialized to 1, but then we multiplied power with a 5 times because n was fixed. But this time, we don't know how many times we need to multiply power with a. That's why we multiply power with a and then count the number of times that we have actually performed this multiplication. So we need a count variable initialized to 1. And each time we perform this computation, we perform this multiplication, we increment the count until count reaches n. That is, when we have multiplied power with a n times, we are done, right? So that's the general idea. That's where the loop. So here is the pseudocode of our algorithm. We prompt the user and get a and n. So both of them are variable numbers. Of course, n is an integer, a is a floating point number. We set count to 1, count the number of times that we have multiplied power with a. We initialize a running power set to 1, of course. That kind of indicates a to the 0. That's the initial value of power. Then we repeat while the count is less than or equal to n. So until we multiply power with a n times, we have to repeat this, right? So repeat while count is less than or equal to n. We simply say power is equal to power times a. Remember, this is the statement that we have to perform n times. We have to do this multiplication n times. And each time we perform this multiplication, we increment the count. So we say, how many times did I perform this computation? So initially, we have performed it once, so I incremented, and I should continue for as long as it is less than or equal to n. And as soon as it becomes n plus 1, that means I don't have to multiply it any further. So I'm gonna, at the end, just going to get out of this while loop and print the power. Here is the flow chart of our algorithm. We start and prompt the user to get a and n, initialize our counter with 1, and power with 1. Remember, the power is our running power. It's a to the 0 in a sense at the beginning. This is our conditional expression or relational expression where we ask ourselves, have we multiplied power with a n times yet? If not, then we go into the body of the while loop, we multiply power with a, increment the count variable, and come back to the beginning of the while loop and ask the same question, have we multiplied power with a n times? If you have not, we again go into the while loop, execute the same statements, and come back. Eventually, count will be bigger than n, which means we have already multiplied power with a n times, and we get out of the while loop and print the power, and that's the end of the. C and C++ provides 3 looping constructs: the while loop, do while loop, and for loop. We'll start with the while statement or while loop. The while loop keeps repeating an action until an associated test returns false. Here's the syntax. While is the keyword, all in lowercase. Then you open the parentheses and close parentheses, and you write a Boolean or relational expression that either evaluates to true or false. If the expression evaluates to true, then we get into the body of the while loop and execute all the statements within the code block within the while loop. And when we reach the end of the code block, we come back to the beginning of the while loop and evaluate the expression again. As long as the expression is true, we execute the body of the while loop. When the expression becomes false, we get the while loop terminates and we continue with the next statement after the while loop. And here is the flowchart for it. So we come in, this is our decision point. We evaluate the expression. If the expression is true, we get into the body of the while loop. We execute all statements in there in the body. Then when we reach the end of the while loop, the control goes back to the beginning of the while loop and re-evaluates the expression. So again, as long as the expression is true, we evaluate all the statements within the while loop. As soon as the expression becomes false, then the while loop terminates and we continue with the next statement after the while loop. Just like if statements, if the body of the while loop consists of just one statement, we do not need to write a code block. So remember, a code block is indicated by an open curly brace and a closed curly brace in C++. And if there is only one statement within the code block, you don't need the code block. You can just write this statement under the while loop without enclosing it with open curly brace and closed curly brace. This is something that you should remember. This applies to all programming constructs in a sense in C++. So here is the actual C++ program that computes a to the n. We prompt the user to get a and n at the beginning. So you can see we get a and n. A is a floating point number, and n is an integer. Then we initialize our loop variable I to 1, loop counter variable, and running power to 1, which kind of indicate is initialized to a to the 0 to start with. Any a to the 0, whatever, regardless of what a is equal to 1. And here is our while loop. So it starts with the while keyword, all in lowercase, then open parentheses, close parentheses, and the expression. And the expression we would like to evaluate is I less than or equal to n, because we would like to execute the while loop n times, right? I is starting with 1, so we'd like to execute it for when I is equal to 1, I is equal to 2, I is equal to 3, and finally I is equal to n, so that the body of the while loop gets executed exactly n times. So if I is less than or equal to 1, n, we go into the body of the while loop, we execute power times is equal to a, we multiply power, the running power, with a again, then increment the loop counter by 1, and come back to the beginning of the while loop and evaluate the expression I less than or equal to n again. And finally, I would be greater than n, and we will get out of the while loop and just print the power. This is example2.cpp, which I'm going to execute. But before that, let's trace this code here. Let's go step by step and see how the values of I and power change. Assume that the user has entered a the value of 3, for n the value of 5. So we are computing 3 to the 5. But again, these are variable numbers, so the user might have entered any values in here. All right, so we come in here, we evaluate. So we are at the beginning of the while loop. We are evaluate is I less than or equal to n. Remember, the value of I is initially 1, and the value of n is 5. Is 1 less than 5? Yes, 1 is less than or equal to 5. So we go into the body of the while loop and we multiply power by a. So power is equal to 1 at this point. When we multiply it with a, it becomes 3. So 1 times 3 is equal to 3. Now we increment the loop counter variable. So I becomes 2. Again, we go back to the beginning of the while loop. We evaluate the expression again. Is 2 less than or equal to 5? The answer is yes, it is true. So again, we go into the body of the while loop. We multiply power by a. So a becomes, the power becomes 3 times 3, 9. We increment the loop counter variable. It becomes 3. We go back to the beginning of the while loop, evaluate the expression. The expression is now 3 less than or equal to 5. Is that true? Yes. So again, we go into the body of the while loop. We multiply power again by a. So it becomes 27. Increment the loop counter variable. It becomes 4. Go back to the beginning of the while loop and evaluate the expression. Expression this time is 4 less than or equal to 5. It is still true. So we go into the body of the while loop. We do again power times is equal to a. So 27 times 3, it's going to be 81. Increment the loop counter variable 5. Go back to the beginning of the while loop. Evaluate the expression. Is 5 less than or equal to 5? Yes, we need to multiply a power with a 5 times. So we still need to go into the body of the while loop. So we go in, we multiply power by a, it becomes 243. Increment I by 1, it becomes 6. We go back to the beginning of the while loop. Evaluate the expression. Is 6 less than or equal to 5? This is false, as you can see. And we get out of the while loop and print out the value of power, which is 243, which is a to the 5, 3 to the 5. Let's now look at the actual code. This is example2.cpp. Again, we are prompting the user to enter a, prompting the user to enter n, and then reading those values in. Again, this is our loop where I is the loop counter, power is the running power that we are, at the end will be equal to a to the n. Let me also trace this program through so that you see that it's actually doing the same thing. So let me go into the debug mode and ask the user to enter 3. So enter 3 and 5. All right, so we come in and we do the same thing. So look at the values of a and I and power on the left hand side. So is I less than or equal to 5? Yes. So we multiply power by a power becomes 3. Increment I, go back and do the same thing. Is 2 less than or equal to 5? Yes. So multiply power by a, so it becomes 9. Increment I, it becomes 3. Is 3 less than or equal to 5? Yes. We multiply power by a, it becomes 27. Increment I by 1, it becomes 4. Go back to the beginning of the while loop. Is 4 less than or equal to 5? Yes. We get again going to the body of the while loop. Multiply power by a, it becomes 81. Increment I, it becomes 5. Go back to the beginning of the while loop. Is 5 less than or equal to 5? Yes. So we get into the while loop, multiply power by a, it becomes 243. Increment I, now I is 6 and is 5, so the condition is false. We get out and print the value that we just computed. So 3 to the 5 is equal to 243. We can actually write this code, the example 2, in a shorter way as follows. Observe that we are doing the comparison using the current value of I and comparing it to n, and then incrementing I inside the loop body. So we can actually combine these comparison and increment operations into one statement like this. We can say I plus plus less than or equal to n. So remember, this is the same thing. So it's using the current value of I, comparing it with n to make the decision whether we should go into the while loop or not. And then increments I by 1. So it's I plus plus. That's why this is a post increment. That's why we'll be doing the comparison using the current value of I and then increment I by 1. And it's exactly the same code. This is example 3.cpp. So let me show you that code. It's right here. So I is equal to 1, power is equal to 1, power is equal to 1. Now I have simplified the previous code by saying do the comparison and increment within the same statement. And now because the body of the while loop only consists of one statement, I don't need the code block. So you can put the code block. So you can put the code block like this. It's not going to hurt. But because it's just one line, one statement within the while body, we don't need to make it a code block. We can just put it like this. Remember, this was the same case with if statements, right? If the body of the if statement only consists of one statement, you don't need to put a code block around the statements in the body of the if statement. The same applies to while statements. So if the body of the while statement only consists of one statement, you don't need to make it a code block. You can, right? This is a code block now. You can put these curly braces, open and close curly braces. The compiler is not going to complain, but it is not necessary. So it's a personal taste thing. Whether if you want to put it or not, it's a personal choice. Typically, people do not put curly braces if the body of the while loop or the if statement contains only one statement. Let's look at a new problem, which is computing the summation from 1 to n. 1 plus 2 plus 3 plus dot dot plus n. We prompt the user and get the value of n. Again, we set I to be 1, so I is the first number in the sequence, then it will be 2, then it will be 3, and eventually it will be n, right? So set the running sum in a sense to 0 to start with. The running sum is 0. So repeat while I is less than or equal to n. Remember, I will be walking over these numbers. So it will first be 1, then it will be 2, then it will be 3, and eventually it will be n, and then we will terminate the loop. So we get into the body of the while loop. We say sum plus is equal to I. So we need to add I into the running sum, then increment the value of I, and then go back to the beginning of the while loop. So when the loop terminates, the running sum should contain the summation, sum of the numbers from 1 to n. So here is the pseudocode for it. Prompt the user and get n. I is initialized to 1, the running sum is initialized to 0. For as long as I is less than or equal to n, we get into the body of the while loop. We say sum plus is equal to I, and then increment I and go back to the beginning of the while loop. When I exceeds n, we get out of the while loop and print the sum on the screen. And here is the code for it. So again, prompt the user get n, initialize I, to be 1. This is your running counter variable in a sense that walks over these numbers. So initially it's 1, then it's going to become 2, then it's going to become 3, and eventually it's going to become n, so that we compute the summation of all the numbers from 1 to n. So while I is less than or equal to n, we get into the body of the while loop. We say sum plus is equal to I. So we are adding I, the current value of I, to the running sum, then increment the value of I. All right, so let's trace this code. Again, go step by step and see how I and sum change. Assume that the user has entered 5 for the value of n. So we are at the beginning of the while loop, evaluating the expression I is less than or equal to n. So the expression is 1 less than or equal to 5. Yes, it is true. So we get into the body of the while loop, and we add sum plus is equal to I. So that whatever the value of I is, we add it to the running sum. Remember, I is 1, so we are basically adding 1 to sum, so sum becomes 1. And now we increment the value of I, it becomes 2. So the next time I will be adding 2 to sum. So we go back to the beginning of the while loop, do the comparison. Is 2 less than or equal to 5? Yes, it is true. So we get into the body of the while loop. We again add the I to the running sum. I is 2 at this point, and the running sum is 1. So 1 plus 2 becomes 3. So 3 indicates the sum of the numbers from 1 to 2. So it's 1 plus 2. Increment the loop counter variable I, 3. Go back to the beginning of the while loop. Now do the comparison. Is 3 less than or equal to 5? Yes. So we get in. We can add 3 plus 3, which is 6. So again, 6 is the summation of the numbers from 1 to 3. So 1 plus 2 plus 3. Increment the loop counter variable, which becomes 4. Go back to the beginning of the while loop. Do the comparison. Is 4 less than or equal to 5? Yes, it is. So we get in. Again, do 4 plus 6, which becomes 10. Increment the loop variable, which becomes 5. We go back to the beginning of the while loop. We do the comparison. Is 5 less than or equal to 5? Yes, so we get in. Again, we do sum plus I. So sum becomes 15. Again, 15 is now the sum of the numbers from 1 to 5. So it's 1 plus 2 plus 3 plus 4 plus 5 is 15. So you increment the loop counter variable, which becomes 6. Go back to the beginning of the while loop, do the comparison. Is 6 less than or equal to 5? It is false now because we have already computed the summation of the numbers from 1 to n. We don't want to add 6 to the sum because that would be the summation of the numbers from 1 to 6. So we get out of the while loop and print the sum on the screen. Just like we did it in the previous example, we can actually write this code in a shorter way as follows. Look at this part of the code. What we're doing is we're doing the comparison. We are getting into the while loop, and then we are saying sum plus is equal to I, and then incrementing I. So if I can actually move this increment operation into the summation operation. If you think about it, what we're doing it, so I can combine these two statements into one statement. So I can say sum plus is equal to I plus plus. Why does this work? Because this statement is going to take the current value of I, add it to sum, and then increment I. So when you extend this into two statements, you're going to get exactly these two statements. So when you have statements like this, you can actually combine them into a single statement like this. And that's example 5. So let me go to my examples. This is my example 4, where I explicitly increment I in a separate statement, right? And this is example 5, where I combine those sum plus is equal to I and I increment into a single statement. And now because the body of the while loop contains only one statement, I don't need to put it into a code block. So like as I said, you can put it into a code block like this, but if you don't, the compiler is not going to complain because there's only one statement within the while loop. And when that's the case, you don't need to put them into a code block. So let me run the code so that you see that it actually works. You can go step by step and debug it for yourself. Let's do from 1 to 5. That should be 15. Let's do, this is example 4, so I can do example 4. summation of the numbers from 1 to 10, that should be 55. Let me also do example 5. So let me also execute example 5, and so that you can see they actually give the same output. So example 5, summation of the numbers from 1 to 5, and let's do summation of the numbers from 1 to 10. That should be 55. Let's now move on to a new example where we would like to print a table of squares. Assume that you prompt the user and get a value of n and print a table like this, where you print the values of from 1 to n, which is, remember, n is equal to 6 in this example. So we have 1, 2, 3, 4, 5, 6. And on the right hand side, you print I times I. So 1 times 1 is 1, 2 times 2 is 4, 4 times 4 is 16, and 6 times 6 is 36. Assume you would like to print this table. How can we do that? Here is the pseudocode for it. So we prompt the user, get the value of n, print the heading. So the heading is this part. So this is the heading we are talking about. We have to print that before the loop starts, right? And then we initialize the value of I to be 1, and it's going to continue executing as long as it's less than or equal to n. Here is the body of the while loop. So somehow we should print I and I times I, right? So we need to write a printf statement because the format of the printf statement, and then increment the loop counter, and then come back. So and when we're done, we should print the bottom line of the table. Here is the actual code, example 6, that performs this. So we prompt the user, get the value of n, we print the header, which is it prints this heading in a sense, and the column width is 1, 2, 3, 4, 5 characters. As you can see, the width of the column is 5. Also in here, it is 5. So we go into the while loop. I is initialized to 1. Do this for as long as I is less than or equal to n. We're printing one line of this table at a time. At each iteration of the while loop, we're going to print one line. Remember, it is 5D because the width of this column is 5 characters. So 1, 2, 3, 4, 5. So it is 5D. D is the decimal. And we're using the printf statement to print the value, which is right aligned, right? And we increment the loop counter. When we are done, we need to print the bottom of this table, which is bottom heading, in a sense, the footer, you could say. All right, so let's trace this through. So let's assume that we have already printed out the heading part, and we are at the beginning of the while loop. Assume n is equal to 4, I is equal to 1. That's how we initialize it. Again, we do the comparison. Is 1 less than or equal to 4? Yes, we go into the while loop. Now execute the printf statement. The printf statement is going to print this line of the table, right? 1, 1. As you can see, these are right aligned because this is 5D, meaning that it's going to allocate 5 spaces. And it is D, meaning it is going just integer and right aligned. If you wanted left aligned, then we would have put minus at the beginning. So again, increment the loop counter, it becomes I. Go back to the beginning of the while loop. Is 2 less than or equal to 4? Yes. We come in and print the next line of this table. It will be 2, and 2 times 2. Remember, it is I, and I times I is equal to 2. So it would print out 2 and 4. And that's what it does. So you get 2 and 4. Again, increment the value of I, go to the beginning of the while loop. Compare 3 with 4. Is 3 less than or equal to 4? Yes. We go into the body of the while loop. Again, print the next line. Because I is equal to 3, we should print 3 and 9. And that's what we do. We increment the value of I. It becomes 4. We go to the beginning of the while loop. Is 4 less than or equal to 4? Yes, it is. We go into the body of the while loop. We again print the last line, which should be 4 and 16. Increment the value of I, which becomes 5. Go back to the beginning of the while loop. Is 5 less than or equal to 4? No, we get out and print the bottom line, right? The last line of the table. And that's how we get this formatted table on the screen. Let's go to this example, which is example 6. It's right here. Prompt the user, for n and get it. This is where we print the table header, and this is how we print one line of this table at a time for n until I becomes n. At the end, we print the bottom of this table. I'm just going to run it so that you see. So let me do it for n is equal to 6. All right, so let me clear this. This is example 6. Let me run it for 10 so that you see from 1 to 10. So it's 1, 2, 3, 9, 10, and this is I times. Here is another while loop example. This is example 7. And I would like you to observe the following. Instead of initializing the loop counter variable to 1 and executing the while loop for as long as I is less than or equal to 10, I am initializing the loop counter variable to 0 and executing the while loop for as long as I is less than 10. So how many iterations will this while loop have? It turns out it still has 10 iterations. The reason is we are initializing I, the loop counter variable, to 0. So that means the loop is going to iterate when I is equal to 0, when I is equal to 1, when I is equal to 2, and when I is equal to 9. So for the values of I from 0 to 9. And if you count them, that there are 10 of them, right? There are 10 numbers from 0 to 9, including 0 and 9, right? There are 10 numbers. That means the loop is going to iterate exactly 10 times. I could have formulated the loop by setting the loop counter variable to 1 and then making the condition, loop condition, I is less than or equal to 10, which is what I did in the previous 3 examples. But sometimes, in some applications, this is the way you need to set up the loop, making the initial value of the loop counter variable 0 and executing the loop for as long as the loop counter variable is less than some value, 10, 15, n, right? Let's now look at example 7 and execute it. As you can see, the initial value of the loop counter variable is 0, and we execute it for as long as I is less than 10. So this should execute exactly 10 times for the values of I from 0 to 9. As you can see, I is equal to 0. It prints programming is fun. And eventually, when I is 9, it prints programming is fun. And if you count them, there are exactly 10 such values that are being printed on the screen. Other way to set up this loop so that it executes 10 times would have been setting up the initial value of the loop counter variable to 1 and then making the condition I less than or equal to 10. So if we execute this, again, this will execute exactly 10 times. But look at the values of the loop variable. They are now 1, 2, 3, 10. In the previous example, it was 0 up to 9. Both of them print out 10 values on the screen, but the value of the loop counter is different. So which one should you choose? Should you initialize the loop counter variable to 0 and make the condition I is less than n, n being 10 in this example, or should you initialize I to 1 and then execute it for as long as I is less than or equal to n? It really depends on what you are trying to do. In some applications, this is the way to go about it. In some applications, some other applications, the other way is the way to go about this problem. It is also possible for a while loop not to execute at all. So if the initial value of the loop counter variable is 20, for example, and our loop condition is I is less than 10, 20 is not less than 10, so we never execute the body of the loop. So let's go to our example 7, and make this 20, right? So if you make it 20, we are going to come here, and 20, we compare, is 20 less than 10? It's not, so we never execute the body of the while loop. So let me just show you that. Let me execute this code, and you're going to see, you just print how do you like C++ programming, but the body of the while loop never gets executed. So just because you have a while loop does not mean it's going to get executed at least once, right? It all depends on this Boolean expression that you have at the beginning. If the Boolean expression evaluates to false the first time you evaluate it, you never execute the body of the while statement. So this ends our discussion on the while statement in C++. If you have any questions, please put them in the comments section.